Next question number 66. Two weight W1 and W2 are suspended from the ends of a light string passing over a smooth fixed pulley is pulled up with an acceleration g by 2. Then the tension in the string will be. We have a pulley system, and the pulley system, we take the mass to be M1 over here and M2 over here. M2 then what will be the weight W1? W1 will be equal to, this is M1G. Understand the we go? Here weight is given in, mass is not given. Instead of mass, we are given with the weight, corresponding weight. W1 is the weight in the one of the end of the string logi among n amada weight set W1 in M2 we will be considering this to be W2 equal to M2G and this is inside a leaf, and this is accelerated upward with an acceleration d by 2. Do you understand the meaning of this statement? Statement that man has the two weight W1 and W2 are suspended from the ends of a light string passing over a smooth fixed pulley is pull up. Pull up means it is moving upward with an acceleration g by 2. Then what would be the tension in the string? We have already understand that if the system or if the body is moving upward with some acceleration, then there must be an increase in the apparent weight. The person will feel heavier when feel the water. That means here under normal condition, what will be the tension? Under normal condition, the tension will be twice M1 M2 divided by this is M1 plus M2 into this is G. This was the formula for two vertical object hanging from a pulley. Stuck in Nico. When I stuck the vertical object, and you have the nangi tension in either string set, either part of the string set, it will be twice M1 M2 divided by M1 plus M2 into Z tagani height. Kangiko. This is under normal condition when the leaf is at rest the leaf case. But in this question number 66, we know that this entire pulley system is moving upward with an acceleration g by 2. Therefore, we have to consider the increase with the M1, M2, this is M1 plus M2, and very simple, this will be G plus A. You get this one? If the body is moving upward, the net acceleration increases, so that the tension will also be increased by a factor G plus A. Very simple. This is 2. Mass M1 can be reproduced as M1. This will be equal to W1 by G. And what about your M2? M2 can be reproduced as W2 divided by Z. Understand the one because Yani very easy. You put the value of M1 as W1 by Z, and what about your M2? This is W2 divided by Z, and this will be what about G plus A? Something as G by 2 plus G. That means it will be 3 by 2. G plus A. G plus A will be equal to, this is G plus, what is the given acceleration? G by 2. After simplification, we will be having 3 by 2G. Therefore, we put the value, respective value. Therefore, divided by M1 will be equal to, this is W1 by Z plus this is W2 divided by Z. And from here, this G and the Z get cancel out, this 2 and the 2 get cancel out, and we are left with 3 W1 W2 divided by Z, and we will be having W1 plus W2 divided by Z. Again, this G and Z get cancel out, 3 W1 W2 divided by W1 plus W2. And we get our answer. Option number 1 will be our correct answer. Anyway, let me repeat once again. Stopping distance let us consider this is body or mass m and this is moving with a velocity u. Initial velocity is u, and after applying brake se apply to matungda it comes to rest at this position. And what will be the final velocity? The final velocity will be equal to 0. That means you have to apply brake for some distance, for some minute. Now minute khara di brake se apply to gaya. Once of brakes kauraga ata gari chelam do stop ata oi brane oite. It doesn't come to rest after the application of brake once. Nang brake to kauraga dum lete ba. You have to apply it for 10 seconds, or you have to apply it for 2 meter distance. 2 meter distance nang apply to din. Brake se dum left bo dum kau din natro. You have to apply the brake till the vehicle comes to rest. See the common concept ni ko. The distance that is to be traveled for bringing the object at rest, that will be known as this is known as stopping distance. Stopping distance is the distance that is required for bringing any moving object to rest. Rest the radi nangi minimum distance that is required will be known as stopping distance, and the time sequence this will be known as stopping time. And what will be the formula? Very simple. Stopping distance d d, we will be using v square equal to u square plus twice as. S, so the s and e s is the stopping distance in the kilo. Therefore, the application of your brake will reduce. Kana reduce to rani speed to reduce to natro. If speeding up waragana, we will term it as acceleration. Acceleration means increase in the speed. Retardation means decrease in the speed. Nangna yang khalakko oitaradi acceleration. Brake apply to kanadi slow down widana. Slow down with case we will call it as retardation, and retardation is just opposite of acceleration. Therefore, in this particular case where we have to find out stopping distance, we must apply brake se apply to vidiko, and this application of brake will produce retardation. Retardation produced to now we have to take it as minus negative on the lower negative on the zero. Final velocity is 0, initial velocity is u square minus. Why minus? Because this is the retardation twice a into this is s, and after transferring this over here, our stopping distance s will be equal to initial speed square divided by twice a, so that we can have the stopping distance directly proportional to directly proportional or initial speed square proportional or see khangani ko ai si kya tabro. I mean, if you are driving the car at 40 km per hour, then 40 km per hour you have to, after the application of the brake se apply it has to run some certain distance, 10 meter, 20 meters move. Otherwise, if you drive at 100 km per hour, 100 km per hour you have to the car after the application of brake apply it has to run 50 meter of the run brake hard, so it has to run greater the speed, greater the initial speed, greater will be the stopping distance. That is the concept over here. Get it? Understand the record? Now let us find out the stopping distance. By stopping distance ki find out the stopping time. Stopping time say stopping time v is equal to u plus at. Now this a must be negative 0. This is u minus at. Very simple enough. After simplification, t will be equal to u by a. From here we can conclude that our stopping time is directly proportional to initial speed. See the basic difference. Stopping distance is directly proportional to the square of initial speed. Yabra, yareko. Stopping time na it is proportional only to the initial speed. Amana square up direct proportional to distance ki oragana. Time ki oragana. How long you should apply the brake have said that will be the stopping time. Yaiko I said, and it must be equal to t equal to u divided by a. Here we consider a to be constant. retardation produced by application of your brake will always remain constant. Nang kau give gari brake se kay no, it is only one type of brake natro. Brakes gari ki brake se this will be one single magi ability है only one type of कोई नहीं है aduna acceleration will be also constant tagani acceleration hai ba the retardation produced by your application of brake will remain constant because brake will be only one type for a given car or for a given vehicle lamagi understood tawre yare by putting this concept in our mind let's proceed with our question number 67 question number 67 है तो question number 67 we have from the diagram we know that m1 is the horizontal mass m2 is the vertical mass a block of mass m1 and m2 a block of the mass m1 lies on a smooth horizontal sida pen tha nungai tare marak sida pham sida yo next up a block of mass m1 lies on a smooth horizontal table and is connected to another freely hanging block of mass m2 by a light inextensible string passing over a smooth pulley situated at the edge of the table. Initially the system is at rest with m1 at a distance d from the pulley. Then the time taken by the m1 to reach the pulley habadi sikayo batare see stopping distance ki oiramdre the question is not related to stopping distance and stopping distance ki da khalu reko anyway see stopping distance hai we will be using this stopping distance concept in our friction ki chapter da discuss tarokani ko so pana time the waste of break tare this is m1 this is your m2 question number 67 now what will be the acceleration what is the distance man pyramid distance kya no distance dm le rekho tell me what will be the acceleration a will be equal to after I was arranging which object matlab which body is responsible for the motion m2 hanging mass na magi responsible within a top m2 will be responsible so m2 is there any opposition produced by m1 opposition of the tawro horizontal mass will not be considered tawro ba gyan dai the m2 divided by this is m1 plus m2 into g simyar ba direct if we get the acceleration nang acceleration khanga taragati what is the time taken hanguna tro what is the initial velocity m1 was initially at rest le record and it will be under acceleration it will start moving in the right hand direction with an acceleration this must we have s is equal to ut plus half at square and ibra can we have this formula s is equal to ut plus half at square initial speed or initial velocity time taken into acceleration into time taken square yai ko this will be equal to 0 c times 0 satra so why madam ji we consider m1 to be initially at rest the letter manina simply this is the can we put like this yaradra time taken will be equal to 2 root over 2t divided by a. You just put the value of a value to answer 0 and you will get the answer very simple root over twice t divided by what is the value of a this is m2 divide m2g divided by this is m1 plus m2 like and this is t so that we will be having our answer as 2d m1 plus m2 divided by m2g root over Yadra? Yariko? Linda, kangi ko. Magbayad din. Paghapo yung drabon. Next topic will be friction. See, friction is whatever we have learned so far can be also be applied to our friction. Friction is applied to wherever. Pulley system, hanging system, the motion of contact system, all can be applied to your friction. Friction is only applied to where. So friction is very important. Your low motion the I know. Can hold the we cannot skip any of the portion. That is why we have to go step by step. This exact question, this will be again repeated in friction, but it will be quite different. So you must have the concept for both smooth surface and rough surface. Question in your examination, your examiner question setter. You have already studied smooth surface and rough surface. Aduna question can be asked either from here or here. So you have to read very carefully whether the surface, given surface is smooth or rough. Now let us proceed to our friction. I point wise with a bullet point on a period. Learning in detail describe the so what is friction? Friction is the opposition to the motion. Opposition to the motion of any object. Object amana motion lai batadi magi motion do oppose tori bado. The force, the external agent that produce that oppose the motion of any object will be known as frictional force. And you should be very familiar with this diagram. Familiar with what will be the two different type of forces that acts on this body of mass m. Weight amalapra mg. And in the previous classes we have already discussed that if any object is in contact with any surface, the surface will produce a normal reaction generate so that action and reaction is maintained. If any object is in contact with a surface, there must be an action and reaction. Action will be the weight, and this surface will produce a reaction in the form of capital R, which is opposite to mg. Yagadra? Yariko? mg is not due to gravity. Surface na karama force pathui. What is the force that is being produced by the surface? That is normal reaction. Yagadra? And under normal conditions, R will be equal to mg. Normal reaction will be equal to weight. If we know the normal reaction, weight can be easily calculated. Yanda bra? Yariko? Similarly, next time we will see. This is the external force applied to the body of mass m. See, body of mass m is the force F. External applied to them. Then, magi body si karon dusat kani. Is it necessary that this given body will be moving to the right hand side? Necessary or bra? In all conditions, it may or may not move. Do you understand the concept here? This is a very 100 kg stone in let us consider this to be 200 kg 200 kg stone in Kalazi. Can you drag it by yourself? Even though you apply force, it may or may not undergo motion. Mas chat pa yan, chat tabi yan. We do not know it. Kami ko, nang nasidali say, I see kami, I see ching is not slow and chik it may or may not. Even though I apply force apply to tayo nang gising body say, it may undergo motion or not. Yay ko. But what is the tendency? My tendency is kayo no. The body has a tendency to move in the direction of the applied force. Mag applied force to be direction the tendency in the libra. Chat pataragadi if the body is allowed to move or if the body undergo motion chat pataragadi this motion will be towards the direction of the applied force. Applied force ki direction sa pra. Ay nasipay ka singe kala jeba. Ma leng ng datar it has a tendency to move to the direction of the applied force libra. Yeah, kangani ko, adudi ay na haningi sa atin na diba while taking your direction of the friction, nang friction ki direction the low madam na you should not confuse with the direction of the friction must be opposite to its tendency of motion. Magi tendency of motion the karon lay tendency of motion is to the right libra. So our frictional force will be towards the left and capital F will represent the externally applied force and small f will represent the frictional force produced by the surface. Yanda bra? Understand to require here is confusion sa pya deko. Simple way na nagi most of the student will take the direction of the friction opposite to the direction of the applied force but that is wrong. I having concept say conclusion the conclusion is that the direction of the friction must be opposite to its tendency, not to the external force. External force the not I having say friction say sidadi for our diagram our external force and its tendency has the same direction, therefore our friction will be opposite so normal person naman just by looking at the diagram he will interpret the direction of the friction is opposite to the direction of friction. The direction of friction is opposite to the externally applied force. That is totally wrong. Gantay ko, mag tendency ang level wrong. Tendency is to which direction? To the right libra. Like, let me give you another example to justify our statement. Quick statement justify to na ba yun ko. So object ang level ko. Si object ko, this object is in contact with the whiteboard. Whiteboard siga contact lere. Ay nas the force man pide. Force ikaron to sali. The force is to the perpendicular direction of the board. Perpendicular direction of the board. The perpendicular is sa pra. Sali. Ano gumay tendency kayle? What is the direction of where should be the book say motion if it is permitted to have motion, this book will not be come in forward direction or it will move in the backward direction. It will slide down. Bro? It will fall down and apply the report. Slide down. It has a tendency to fall downward. Slide down. That means even though we apply force in this perpendicular direction, our frictional force must be taken up the whiteboard. Yagadra? Yariko? Concept clear with it? Nanga, if we go through the initial concept, smile over say, this is the applied force of the see applied force if the frictional force is taken opposite to the applied force, our frictional force must be opposite to the applied force. It must be perpendicularly outward going in. If we go through the same concept, but in reality, what is the tendency? The tendency is to fall vertically downward. Our frictional force must be up the whiteboard, even though the applied force is perpendicular. The direction of the friction must be taken opposite to its tendency of motion. Mang tendency ko the line right hand side left na retarding frictional force left side the board. In short, let me conclude over here. Sidali is a body M set. The magi force kya act away after completion of our total force discussion. See discussion complete. What are the four different forces that acts on this body of mass m? Force like there will be four different forces natra. Ahanbada weight ama leiraba, mathangda external force ama leiraba, surface the force kya puthoi? Surface the puthoi se it produces two different type of forces produced. Number one will be the Norman reaction. Number two the kai frictional force produced. Here under this condition, the rough surface produces two different type of force. Number one the Norman reaction. Number two the frictional force. Yeah. Smooth ki hoita ni yogi. Smooth ki hoita ni it produces only kana produce Norman reaction produce. See the basic difference. If the surface is smooth or batarati, it will produce, the surface will produce only Norman reaction. And if the surface is rough or it has some friction batarati, that the rough surface will produce two different type of force. Force ani kutokani one kana say perpendicular to the rough surface, that will be our Norman reaction, and another that is along the rough surface, which will be known as frictional force. Yaradra? Yare khangani ko se. Now when I simplify on here again, this is body of mass m. We consider only the mass, only the force that is produced by the surface. Surface to produce the this is frictional force F. This is our Norman reaction R. So we have this is force, this is a vector, this is also vector, so we will have a result. Do you understand the concept here? If two vector force it is a vector quantity, so if two vector are aligned, are inclined at angle theta, this is A vector, this is B vector, then we will have our resultant vector in between, and this will be written as A vector plus B vector in terms of vector equations mindset drop. Understand the this will be our resultant F resultant. See the basic difference. See the frictional force F resultant natraga net force produced by the surface the resultant frictional force will be equal to kya managani sir. This is lambda ne khalajiko. Lambda will be known as our angle of friction. Lambda is known as angle of friction. So define angle of friction D. It is the angle between the resultant frictional force produced by the surface along the direction of Norman reaction. Norman reaction jiga mabani ki total amala akra laktabra F resultant ga frictional force ka F frictional force का reaction के मबानी बरतल एवं resultant तो ना Norman reaction का angle क्या semi, that angle will be known as angle of friction. And सीधे ना सिर्फ क्या होगा बता रहे हैं, this will be F according to our Pythagoras theorem वो इधर यदि from here to here this is F resultant. Can we write like this? F resultant will be equal to root over base square plus perpendicular square. Can we write like this? See याद रहे अभी तक क्या तरह किसने कहा था सीखंगो बुरा गाँव देखो अदु इन्ना सिस्टम है रो tan of theta tan of lambda में है तार दी tan of lambda will be equal to F divided by R and E में आपने तब रहा यार सीखंगे देखो. In short I mean is kind of very simple the angle made by the resultant frictional force along with Norman reaction will be known as angle of friction, and angle of friction can be calculated by taking the ratio of frictional force produced by the surface along with Norman reaction. Norman reaction ratio of see now basic Nicole I said. Now we will classify our friction is classified as Z. Before that we have to go through our law of friction term Z. Law of friction is very simple. Our frictional force F will be directly proportional to Norman reaction. Frictional force is directly proportional to Norman reaction, and after finding out after converting this inequality into equation mu r minus like it. Frictional force F will be equal to mu r. F equal to mu r. See, so we can have this as mu mg any under normal condition. Under this condition, we can write like this: mu equal to mu mg. Or in short, the frictional force will be equal to coefficient of friction multiplied with normal direction r. Yaradra? Yareko se? Confusion sa pati. Now, type sa na yung asi. Saying as I 2 kg lo rase ba sige 2 kg se kya no what will be the weight mang weight se kya lani 20 newton na tagadra 20 newton tare ko what will be the normal direction r will be equal to 20 2 into g 2 into 10 it will be 20 tare ko. Now let us consider the frictional force applied force na kya name lo sige sige ito ko se simple way na tagi kanang hilis dere is let me skip all the intermediate explanation. I don't skip taroge what is important do adu katanga explain taroge. We consider an example mo pile ko sige examples the we have this body of mass m this is acted upon by an external force equal to 50 newton act tawreba aduga the frictional force that develops between the contact surface of mass and the surface kaya ore it comes out to be 100 newton ore. Will the body be at rest or will it be in motion? Rest da legadra motion da legadra karamba legani sa ekta haro rest da legadra lerodro rest da lego hai chappa nga maroi ba manas leise external force will be responsible for the motion of this body. Frictional force na responsible for stopping the body, for stopping the motion. Motion do stop to hangyara na friction. Al motion do cause to hangyara. This is the cause. Sina cause diko. Motion do produce to diko cause na traga produce. Sina kayo gani it will oppose lakta bro. Like opposition ga kanaga mag production ga si kanani heli. Which one is stronger? Opposition is stronger bro. Oireko. So the body of mass m will be at rest. Rest na leraba. Under such condition, the frictional force developed will be known as static friction. If the body is still at rest, after the application of force, then the friction that is developed in between the contact surface of body and the surface, it will be known as static friction, and this is a self-adjusting friction. My meaning is self-adjusting height. Like self-adjusting height is you have 100 rupees in your pocket and you want to buy any item worth rupees 50 will you spend 100 rupees? You will give only 50 rupees for buying the object. Object notebook 50 rupees. If you want to buy it, you have to give only 50 rupees, even though you have 100 rupees in your pocket. Nangi pocket 100 rupees you cannot give the total amount. Whatever in your pocket what is the total frictional force that can be produced by this surface? Surface na produce to total the total frictional force that can be produced by the surface is 100 newton, and sige 100 newton out of this 100 newton only 50 newton will be used or will be utilized in order to oppose the 50 newton that is that tries to produce your motion book produce to na honor 50 newton je overcome to no 50 is enough. Let us consider this example am ko classroom mum le this is classroom of 100 people le 100 student le 50 student attack to re ba koi 100 to pull up hoga defend gadra. No, we will defend by sending only 50 people khak natro 50 after 50 is enough and have natro yai ko adu whatever is required to it will be taken from this total reserve. 50 is required, so you take out 50 rupees from our pocket khangani ko 50 people attack to ta di kai this is the external attacker neva intruder neva si attacker neva ma defend to na ba we require only 50% require bra just like that my high tare and static friction will be self-adjusting friction and it will try to adjust according to the externally applied force. Nang 50 Newton oita di 50 the moy gani sida 70 oita di nang 70 Newton applied to ta di out of this 100 70 will be developed. Only 100 every from the 70 will be developed over here. It will not develop 100 to develop to roy. Gyan tabra understand to mo mi ko hai if you require 70 rupees required to you are not going to spend 500 rupees spend to withdraw. You will spend only, even though you have 500 rupees, you will spend only 70 rupees. That is why I adjust myself in according to the cost ki matungina adjust widna just like that. Even though we have 100 Newton, we will adjust according to the applied force ki matungina lakhan yadra yare ko se. This is our concept number 1. Static friction high taragadi this must be at rest, the body will be at rest. Yare simta lagi ko simi yare lagi next tam yung kasi limiting friction. Sida mana le ise under this condition the F external siga nagi frictional force ka mana batara dine total frictional force available siga external force ka mana ta the body will be at rest but rest le iradi adugo it is about to move ala tabra about to move. When the body is about to move, then now we will have a condition where external force applied will be exactly equal to the total amount. Total frictional force that is available to the surface का external force का माना बता रहे there will be known as limiting condition. Limiting condition ले रखो 70 people कोई सिले इसे 70 people ने कल 70 people ना attack होता है each and every person has to come out to defend the classroom. याद आया? Understand तभी को if you have 500 rupees and the cost of the item set 500 हम ताता रगदी Magi, you have to spend all the 500 rupees type of. Hello? Limiting condition that the body is about to move here in this condition your maximum friction will be developed. Limiting case the maximum friction will be developed. याद रहा यार को क्वेश्चन खड़ा बोला जैसे Question number 83. Sida nang na ay na hay to logic am lay ko. Sida theory में आपसे कोई चैप्टर होगा. Theory में आपसे सारा दिन में तैयार हो. Simple logic था. For any question based on friction, first of all you have to find out the normal direction. Normal direction ना find out तो होता है. So now, ladies, remember we have three different type of friction. First one will be static friction. Second one will be our limiting friction, and the third one will be kinetic friction. When the body start moving, body is not set back or that will be considered as the friction that is developed when the body undergo motion. Motion that mana develop friction that will be known as kinetic friction. And your limiting case will be the maximum, and static will be static may or less than may or less than the limiting case, and kinetic friction will have the least value. So when the body start moving, it is very easy. When a stone object if we try to drag it, initially it will be very hard for us to drag. If it start moving, it feels lighter. When the lighter way very heavy when filter with once it start moving, we feel lighter. Hand drag over the lighter in a filter because we know that kinetic friction is the least friction. Friction the least our opposition to the motion is the smallest, so we can easily drag it. Understand the when the body is about to move, it will have the surface will produce maximum opposition to the motion. Maximum resistance. After overcoming the maximum resistance, it will have the least. I maximum effort I oppose to the I opposition overcome just like that. Limiting will the maximum, static may be equal to our limiting condition, and kinetic will have the least value. Manapiri says that we have two different coefficient of friction. One will be static friction and another will be kinetic. You just look at the value. Value is being 0. This will be 0.2. This is only 0.15. Which one is greater? Static friction is greater. What will be the total amount of friction that is available over here? Weight will be equal to mg. Mass is 1 kg. G will be 10 log 10. Normal reaction ji kailani. Normal reaction will be 10 Newton. Aduga silver friction force develop se kya tarani. According to our Fs se kya tarani. Static friction or the total friction that is produced by the surface will be equal to kya manarani mu s into this is r. This is the total available. We have to calculate the total available. How much money do you have in your pocket? According to that, you will manage your buying capability. Pocket 100 rupees 1000 people item to lay now we have to find out total frictional force that is available. Mu s will be 0.2 and this is 10. 2 Newton. The maximum frictional force that can be produced by the surface is 2 Newton. Maximum now let us consider the case number 1. Case number 1 is the this is 1 kg. What is the total friction force available? 2 Newton. What is the external applied force? 1 Newton. Will the body be at rest or will the body be at motion? Move to the body will be at rest. That means it will be static condition. What will be the actual frictional force that is developed due to the application of this external force? External force na maram moiraga develop to the actual frictional force it will be 1 Newton. two person like only one person come and attack with only one person is required for defending it. Yeah, go. Si kangore self adjusting mo bagi. Understood tau ngami. Yare next number 2 da mo yang asi. Our calculation will remain the same. Here, external applied force is 1 Newton and our total available frictional force will be 1.96. This is still greater Vanina. The actual frictional force that will be developed will be only 1 Newton for our case number 1. Case number 2 the case number 2 the externally applied force is given as 1.96 Newton number period and our total frictional this is 1.6 so that F static will be equal to F limiting manabra and we know that F limiting is equal to F external, that is 1.96 Newton tabra. The body is about to move under the application of 1.96 external force. External force to na 1.96 over the body of mass 1 kg is about to start motion start about to move. Next number 3 the kai number 3 is the Nico. Most of the students na land say this is 2.5 Newton tabra. Since the externally applied force is more than the total available friction, the body is about to have its motion. The body will start moving later. Once the body start moving, will the surface produce this much of friction? I know explain once the body undergo motion it will lower its friction. My friction to lower it will be now converted into kinetic friction the convert once body do na motion start our opposition produced by the surface will decrease in the form of kinetic friction. Kinetic friction that decrease we cannot take the actual value of our friction to be Fs in the low. We have to take our kinetic friction in the low with the low withdraw. Total available is 1.96 and what is the externally applied force? The externally applied force is 2.5. This is way more greater than that of the available. The body will start moving. Once the body start moving, the type of friction that is produced by the surface will be kinetic friction and this will be mu k into our normal direction. The mu k is 0.15 into normal direction will be mass into this is 9.8. You multiply this and you will get the answer. 14.7 tabra. Pero ay to iladro. Ahum mo point ahum ka 1.47 lati atra. Lati this is 1.470. Yarba. Magi total available se kano? Total available se 1.96 over. But once the body start moving, out of this 1.96 it will not come into play. Magi friction surface na produce to this it will not produce 1.96. It has the capacity to produce 1.96, but due to the motion it will produce lesser than it, about 1.470 will be produced. Yadra khangi koi hari se yare. Now question number 84. Question number 84 se this is theoretical question as well as nangi question ju jaure aduga theoretical question ju ore ko animak se nang iram du se question ju da pulling ga pushing ga zakara ne numai. We consider a rough surface. See rough surface am lere bag am lere. This is one bag 100 kg of rice bag am lere ko nang na swaina si tor this one ching ke pull ko bra sina kai ko this is pulling sina kai ko this is pushing na ko bra ko da bra push ka pull ka se kana hai na numai. Push and pull se which one will be will be advantageous to us karam ne numai swaina pai ching badi numai ko in badi wai kana jan tai ko kon swaina push to badi ne if we push any object and it feel very heavy will feel taweba. However, if we drag or if we pull from this side, pull back to the same particle can have motion. Nang push the woman it cannot have or it may not have motion. The lack of when you pull with the same strength, the body will start motion. The select the bra. Aduna simple logic to combine high. Our pulling case will be more advantageous than pushing case. A concept of physics in high taragadi friction in your pushing. The pushing friction say this is pushing friction will be more than now when it's a pulling friction. Friction hearing koi what in a throw. Yeah, more friction means more energy is to be used. More energy used to we will feel tired. Koi what in a trap. Live na energy absent the vida sing we must pull. No the kangu ko maning the swing in bino mamang sing over. In the front if you drag any object in front of it, nangi my mamang sing the pull we will have least friction or mina, it will be very easy to pull. Yagadra, let us see the basic difference between your pulling and the pushing case. Diagram of side by side you go. Right side na pull ki ho, left side na push ki ho. Number A is karma case now. This is the pulling case at an angle theta. At an angle theta, the pull to bunatra. F equal to mg in a p minus the F equal to mg in a p vertical the same angles क्या ना this is angle theta in a p the angle that means your externally applied force makes an angle theta with the vertical direction the angle theta da soina pai da soina thora injil ching ji wa ne tak dumlap to ra ko incline to ching bus nai lighter oi feel to ra why ai na hai se simple logic ni ko no na khallo ba se back se सुमाइना खितंग इंक्लाइन तौरगा चिंगसी दिस इज बैक सी बैक हम लेब नत्रा से सी बैक सी इंक्लाइन तौर चिंगता री लाइटर रिफिल तौर अदु नतबा होराइन बैक सी सुमाइना होराइन देलो इन लेरे खलसी ने सिदा नंग चिंगता रदी मोर एरिया इन कांटेक्ट विद द सरफेस लाइटना अदु इताडी इट विल प्रोड्यूस मोर friction होगनी है अदुना नन लव चिंगो मतंदा you should try to drag it by keeping or by maintaining the least surface area in contact with the object. Surface to ga object to ga se least surface area contact maintain tawno ko na while pulling no. Hangi ko that is why we incline at an angle theta. Si angle theta dai chingba taragati we will have the least area of contact between the rough surface and the object. Yare this is mg we will be having mg wet. Similarly, now see force F say this force F will be resolved into two component and the result of we have. So the components this will be F cos of theta. See understand the mugamra money if you want to resolve any given vector in the direction with which it makes angle theta. Angle it will be F cos of theta. Understand tawre? Next perpendicular na this will be F sin of theta antabra. Yani ko normal direction naman sa laigadra leroidra. This surface will produce when we consider we consider the external force that acts on this body of mass M. External force will be the weight say now this is also the external force produced by gravity. Gravity na produced the external force na tro. This is external never. We complete for external forces to complete antawre. Mg gravity. F na externally applied. We resolve silolo reko. Now let us discuss the forces that is being produced by the surface. Surface na produced the magi force to discuss the result ko. Ahanbada normal direction. Normal direction will be in this direction. Simi abra tabra. Then we have this is normal direction produced by the surface. Kangani ko. Next step kailare. The body has a tendency to move to the right hand side. Magi force to right hand side apply to banina. It has a tendency to move to the right hand where banina. Our frictional force will be in which direction? In this direction. The black bro. See F this is the frictional force that is produced by pulling case. Pulling case understand the so we are done here. Nangi diagrammatic representation two external force. One will be the given force F equal to mg. Another will be its own weight mg acting vertically downwards. Yadra yare next the surface the putokpadi normal direction r amaga nangi frictional force for the pulling case amaga adudi nanga sidagi khangado se kai khangado no normal direction sida di under normal condition the r is equal to mg ena logidana. But in this condition we cannot take r equal to mg because the upward force we have the combination of normal direction along with F cos theta libra. We may have along the vertical direction the combined half bata rahe. Along vertical direction we have r plus F cos of theta is equal to mg. From here you have to calculate normal direction r equal to this is mg plus minus F cos of theta. Understand tawre? Kyan tay ko yari se? Hai bidi normal direction sida force hai. If the force is applied horizontally applied karambata the normal direction no, we take it as mg ka manan logo na tro. But the externally applied force is inclined at angle theta. Therefore, we cannot assume the normal direction to be exactly equal to mg. mg का direct equal in low way आती है. क्या तब r equal to mg will be taken. Normal direction is exactly equal to when mg only when the externally applied force is horizontal. Horizontal होई मतलब क्या तरह see the basic difference खाने को. अदु now for any frictional question you have to first find out normal direction because nangi kana low tare kuna we know that friction ki law madugina di F is equal to kai manaba mu r manaba natro. First of all, we have to find out the normal direction. Once you find out the normal direction, we can have the frictional force. Yarani, yareko. This is you say F pulling will be equal to kya manarani. This will be mu into this is r. Here this will be mu and this is mg minus this is F cos of theta. Mani biabra. Yaiko, understand tawre? Kay gino se? Because F is given to be mg ka mana piraba. Pire. Ado di nang simple condition ta. Under this case, F is equal to mu mg tabra. If the force applied is alright, jalo ne applied to batara our friction is mu mg. However, if we apply with some angle that applied to batara, the friction is reduced. The friction is reduced by this factor. Cos factor is reduced to ura. See the smile up to throw mu mg minus mu mg. This is cos of theta. That means something is subtracted from the actual frictional force. That means friction decreases when we apply the force at some angle. Get that go? Adunani aina before the start of this question, I have already explained our reality. Reality is that when I just have a fighting with the wire. Aduna we have to incline at some angle. Incline at some angle, whatever we pull it, then it will be very easy for us to pull. Yeah, bra. Understand the reco? In your pulling case study, our friction is reduced by this mass of factor mu equal to mg cos of theta. Rakesh, lao sida sum option lo. Kanga sa mu mg ma decrease ta ura tawi aduna tai dikai se our pulling force pulling frictional force is decreased. Alright, tell apply to matamda our frictional force develop will be mu mg. But when we pull at some angle theta the pull to batara our friction is reduced by this factor. See, factor is not decreased to ura. The friction decrease or it can have motion very easily. Yeah, easily chatta yabra. Yeah, here see now we are not done with our evaluation for complete with the reco. This is up to here. This will be the theory with Nico. Now let us consider for our pushing case. Push the weak case ang ko. This is body of mass m om lere. Mana push the angle se kya da push the way at an angle theta da push the ura tawi ko. This will be F equal to mg. Aina sida sumaina extend to maram se karigino hai taragadi ne very simple oina nang lawdi se because nang na sidi ko taradi if you draw the diagram as even in your question it will be very difficult lugane ba aduna we extend the line of action lawre sida le force to we extend up to here so extend to reko karigino very simple oina magi body is the act force kya warani. We consider external forces that acts on this body. Force act F equal to mg. This is given external pushing force ni, and we have mg labra. Man angle se kya pyramid? What is the angle made by this? This is theta pibra. According to our geometry, these two angles are vertically opposite tabra. Do you understand? Line and this line intersect this angle and this angle will be known as vertically opposite angle. According to the diagram, we don't have this mass. Only this mass is given atra. If this is theta, we extend our concept by using line of symmetry. Line of symmetry extend vertical line. This angle must be theta. Understand? Now we resolve the component of this given external force in two directions. This will be F sine of theta. Sina karondo bitara, this will be F cos of theta. Understand tabungami? The given external force is resolved into two components, F sin theta along the horizontal direction and F cos theta in the vertical direction along with your mg vector direction. Namtu seminar ba? Seminar. Yare ko. Next time in masi. When external force act over the lower, one is given in your question, that is F equal to mg, which is pushing force. Another will be weight produced by gravity, mg. Yare ko. Now, what are the two different forces that is being produced by the surface? One surface na produced over force kya hogi no? Normal direction amo lakra. We have to consider the normal direction which is perpendicular to the rough surface, and another will be yemo body ki tendency se kai legani. What is the direction of its tendency? The body has a tendency to move to the right hand side so that our friction will be in this direction. Sini kayo betar F kana betar pushing case samlak rolak tabra. Understand tawi ko? Adu we are done with all the forces that acts on this object. See objects the force kya act tawi. Initially we have three different forces lere. Number one, the externally applied force. Number two, the kayo betar weight mg lere. Number third, the normal direction lere. Number four, the lere pushing force lere ba. Lere loin mag result tore ko. Now when I was this kayo betar. For finding out our frictional force F, frictional force F, the first step should be normal direction. Our normal direction will be exactly equal to F cos of theta plus mg. Yadra, yareko. The only force that is acting in the upward direction is R. The total force that is acting in the downward direction is F cos theta plus mg. Plus, do you understand why I take the addition of this F cos theta and mg? You take the simple analogy of you and your friend dragging any object. Yandabra? I did none object of pirate cinema, nang heavy filled with your friend help the easily dragged away. That means your friend is helping you, not helping you means plus addition. Aduna F cos theta plus mg. Physics nothing ko intelligent logical interpretation yare. Now as we khang tarati F pushing di kya tarani? F pushing will be equal to kya manare? Your mu into our normal direction R. That is Kelani said F mu into this will be mg plus mg cos of theta tabra. Therefore we will be having mu mg, this is 1 plus cos of theta tabra. That means if we extend the same logical interpretation, mu mg, this is plus mu mg cos of theta. That means our friction is increased by these factors increased over. More friction more energy is to be used for pulling the object. Is that understood or not? Adunani pushing the D due to the greater friction, due to the greater friction in our pushing, we prefer pulling. Pull to like friction is less. Yareko, if you find this concept, pulling, which one is better, pulling or pushing? Pulling is better than pushing. Why? Because of the lesser friction. Friction law less poem. Yadra, Yareko. Sina, this is up to here. This will be the theoretical section. Theoretical explanation. Now, let us come to our question. The last. Question is, I see what ki ko. Ma'am, what is one hangadi? Sida, sita unim mang sida. I come la kara ige, si pa bugodom ni. Sine of 2 theta si kya mani 2 sin theta cos theta yare ko si formula se ke this is known as dangi multiple formula ko we ko habidi if we consider the sine of twice the angle when consider to utaradi it will be 2 sin theta cos of theta amla abra la e now sin theta utaradi can be represented as it can be represented as sine of theta 2 times into this is theta by 2 can we express like this usually express the way abra yeah देखो it will be equal to 2 sine of theta by 2 and this will be cos of theta by 2 understand the mga madra ngamani ko sina multiple formula this is sub multiple formula yeah now let us discuss for your cos ki we discuss tab si cos of 2 theta se it can be expressed as in two different way this is cos square theta minus this is sin square theta and what will be the second expression will be 2 cos square theta minus 1 and this is cos of 2 theta here if we extend this is the main formula niko main expression this is the reduce fast reduction we can put it as 1 plus cos of 2 theta is equal to 2 times cos square theta yagadra simi yare ko ai aise kya ta ho yarani 1 plus cos of 2 theta utardi this will be 2 times cos square theta now let us reduce this exact formula in terms of sub multiple the convert to behind taragati nang kamai no matare se 1 the cos of theta se kamai be cos of theta can be written as see this in the logo this is 2 cos square theta by 2 minus 1 can we put like this some multiple formula da theta utardi see step se hapa ya bro just like this mana pe na we get this here see just now transfer to it will be 1 plus cos of theta will be equal to this is 2 times cos square theta by 2 see me yaadra yani ko this is reduction nam lai now aina samjha lagamu ige ko sida if we have 1 minus cos of theta or beta radi it will be 2 times sin square theta by 2 la kane minus oragana sin da lakpa plus oragana cos da lakpa remember to ruko we are going to use this over here next time we see what is the question number para ge see question number kya no this is question number 84 see je aine yam sang hole na nang exam da sumaina sang hot to dum late you have to this question has been asked 2 or 3 times hangare ko you have to remember the diagram along with the answer the diagram was simha pungdumni ko concept kambiro concept is that pulling case will be easier than that of pushing yarani ko and what is the answer will be we will find out now was it question jab tak paramge yau ko question number 84 the a block of mass small m rests on a rough horizontal surface as shown in the figure A and B. The coefficient of friction between the block and the surface is mu. A force F equal to mg x and angle theta with the vertical side of the block. Find the condition for which the block will move along the surface. Karino. Karamba condition mana piramide. The body will be moving along the horizontal direction. Sida yung horizontal direction sa patara di kayo we have two horizontal force one will be F sin theta another will be F pulling force ma bibra which one must be greater kana na sa hum thui F sin theta must be greater than your opposing force F pulling is the greater oibam thoi ko. Until and unless this F sin theta is greater than F pulling force, then the body will not be moving. In order to have the motion, this F sin theta must be greater than F pulling. So according to our given condition, our F sin of theta must be greater than must be greater than equal to F pulling of this is the condition. We simply put the value option below. F is equal to mg, this is sin of theta, and here c mu mg into 1 minus cos of theta. 1 minus cos of theta we have this is 2 sin square theta by 2 we put it as 2 times sin square theta by 2 I one single step deduction shorten to mg get cancel out now sidamula sin theta can be expressed as 2 sin of theta by 2 and this is cos of theta by 2 greater than equal to this is mu into 2 into this is sin square theta by 2 and 2 and the 2 get cancel out 2 cancel out 1 sin theta by 2 and this square get cancel out and we are left with and then we sin transfer to sorry cot of theta by 2 is greater than equal to mu yareko yan tawi ai si find out to is pulling case natra pulling the number a ra b ra number a ki natra number a ki kya tare award coefficient of friction must be less than equal to cot of theta by 2 option number 1 will be option number 1 will be our correct answer 1 is correct answer ta natra therefore sidam reduce to see cos की क्या रही है 2 cos square theta लग रहा mg cancel chalo and after all the calculation is done we will be having our this is 2 sin of theta by 2 and this is cos of theta by 2 and we will be having this is mu times into this is 2 cos square theta by 2 here square and the cos theta get cancel out 2 and the 2 get cancel out we will be having tan of theta by 2 is less than equal to mu. See Zamela you forget everything what I have taught. Okay? I just remember to be sick. Remember to be wrong. Nangi pulling case at some angle theta we will have cot of theta by 2. Yaraba cot Lakaduba. Hanganiko Aduka pushing your organa 10 Lakaduba. Adu di mid usalaga nang low di cot katin gatagib natra. Answer the code katin yaw sikram yawi ani mag yawi ko option number 1 ka option number 3 yawra 50-50 chance tilo wi aidana gyan tai ko yare ni losala je hayeng na last class ho gani low motion ki